Hello, hello, test, test. Hello, hello. We're good. We're off now.
Yeah, you're off.
Okay.
go?
You go first.
Okay. Yeah. Hello. Hi. This is the build stage. I think they did a pretty good job. It is big enough for me, so that's good. And it's awesome to see people I know from Twitter, people I know from real life. But I'm very excited to MC the build stage. We have a great set of speakers. The first is Greg, who is the head of developer experience at Supabase. And he's going to talk about the big announcement from this morning, the Supabase Mcp Server. So Greg, come on up to the stage.
Hello, test, awesome. Thanks, Alana. Yeah, so as Alana said, right now I'm leading DX and AI at Supabase. So super stoked to chat more about the MCP launch that Koppel mentioned this morning. And also because I like to torture myself, I might attempt a live demo at the end of this. Someone convinced me right before the presentation to do this, so we'll see if we have time for that. All right, so back in April this year, we launched the initial version of our Supabase MCP server. This allowed you to connect your favorite AI agent, like Cursor or maybe Windsurf at the time, with Supabase. So this meant that you could continue to use your favorite AI IDE while also giving it like a full view into your database. So practically speaking, you could do things like list tables, but maybe more useful, you could actually use it to help you create new tables in your database or maybe modify columns, all while following best practices like storing these in database migrations. And to be honest, though, I think for me, the real value of MCP in general and Supabase MCP is the fact that now everything can just be in one place, right? You as a developer no longer have to like context switch, jump between your IDE, Supabase dashboard to get what you need, come back. It's all just centralized, which is awesome. But there were some core features missing initially. You guys said, what the heck, we're missing edge functions. And of course, if you're building an app and the built-in REST APIs that are auto-generated don't do what you need, you're probably going to lean on edge functions to build kind of the custom APIs that you need for your app. So we said, what the heck, you're right. So then we added the ability for the LLM to actually create edge functions through MCP as well. And this actually worked really great for a lot of people. So actually, as of the past couple months now, we're seeing over 20,000 monthly active users with our MCP server. So clearly, this is the daily driver for a lot of folks, which is super awesome to see. Now, of course, every story or presentation, at least a good presentation doesn't go through without a couple challenges, right? So we'll start with challenge number 1 with our MCP server, and it's basically this command right here. So assuming some of you guys have actually tried using the MCP server, you're probably familiar with this command. This command is actually running the server locally on your machine using Node.js, using the command npx. And it turns out that this command is actually pretty inconsistent across different environments. So first of all, of course, you need to be running a specific Node.js version. That's what npx is doing under the hood. So that's kind of a given to have that set up properly. But also at the same time, it turns out this actually runs differently across different operating systems. So if you're a Windows user and you try to run a lot of these commands, you probably have hit walls. And Windows goes about this a different way than Mac OS. It goes different than Linux. And it's just, in general, a big pain point. So much so that our #1 issue on our MCP repo is literally this. To this day, yeah, there's just been tons and tons of reports of people having issues with this command. We went down a huge rabbit hole trying to get it to work with as many environments as we could, but it's hard to cover everything. That's challenge #1. Challenge #2 is personal access tokens or authentication in general. So how do you authenticate this MCP server or like your MCP client in general with Supabase, like your Supabase account? So to make it work in this context, you would have to literally go to the Supabase dashboard, go into your settings, generate manually a personal access token, come back, pop that into this CLI command argument, And then on top of all that, remember to never commit this to Git, because if you do, you're probably going to leak your credentials. And sadly, there were some cases of this happening. So security, not as good as it could be. And last but not least, you might have heard of this web app called ChatGPT. This one, they actually added support for MCP as of last month, which is super exciting. It's available in like their developer mode is what they call it. But of course, this only works if you have like a remote MCP URL. You can't pop in a npx command like this. Of course, that's not gonna fly. So for all these reasons, we're super stoked to now, as of today, release our remote MCP server. Thank you, yeah. And the best part is as simple as using this URL right here. So this is personally what I love about it compared to everything that we just went through. You can just copy and paste this into your client of choice, Cursor, Cloud Code, whatever you prefer. And that's pretty much all you need to get started right off the bat. And this also means for the first time, you can actually chat with your Supabase project directly from ChatGPT. So you can do this today. So this example, we're chatting with the table. What we have in my database is giving me exact insight into my Supabase project. The other thing that we added to the remote MCP server is what the spec calls MCP auth, which if you've gone into this rabbit hole, this is basically OAuth 2 under the hood with some extensions on top of it. So to be honest, this was more than half of the work to get the remote MCP working is getting all the OAuth stuff working as well. What does this really mean for you? It means that there's no more personal access tokens. No more copy and pasting tokens, no more risk of committing them to source control. This demo here is using Cursor, where essentially you just pop in the URL, you hit that connect button, it's gonna pop you over to your browser, you just grant access because you're already logged into your Supabase account, and then it pops back. So the typical OAuth flow that we're all used to. And actually, we had our eyes on this flow since pretty much the very beginning, but of course, this only works with remote MCP servers. It does not work with the other one's called a standard I/O approach. And this actually is the one that I'm most excited for of them all, and this is actually the ability to run MCP completely local on your local Supabase stack. So this command here, Supabase start, this is nothing new. If you're familiar, this is actually running a full local development stack on your computer. Under the hood, this is using Docker to take all the Supabase services and run them within containers on your machine. And this is kind of our standard local first approach. And up until now, there is really no good way to connect MCP with that unless you just wanted to use like the Postgres MCP and do a direct Postgres connection kind of thing. So also as of today, you can run Supabase start with the latest version of our CLI, and you'll now get this new MCP URL at the bottom, and you can connect this to your, like all the other ones. You can connect it to Cursor, Cloud Code, whatever your preferred client is. And it's actually, I don't know why I was surprised by this. It's like really fast, of course, like what's faster than local? Yeah, it shocked me just how nice it was to work with. So as a summary, if you're connecting to a hosted version of Supabase, you would use this URL. And if you're connecting to a local version, use this URL. OK, so that brings us to today. Some things that I would also love to go through is some other features we added to the MCP server itself in terms of tools and ways you can use it that I think you guys will find hopefully useful. So feature number one is what we call feature groups. And this is the ability to essentially choose which tools you want to actually expose to your clients. And this is useful for two reasons, or at least two reasons that I can think of. So reason number one would be lots of clients, like say Cursor, actually will limit the number of tools you can have or MCP servers you can connect to Cursor. At least this was a previous limitation, but in general, LLMs can only have so much context when you're providing tools to it. So I think by default, our MCP server exposes like over 25 tools, and say Cursor's limit was 40, then you're already eating up like a large budget of tools available, right? And if you don't actually care about using all these tools, you only want to actually have access to your database and maybe some debugging tools, then you can scope that down and have more control over that. The other reason why this is useful is for security. Let's say that you never actually want your LM to ever access edge functions on your project, but you want to give it database access, or maybe vice versa. Don't touch the database, but help me create these edge functions. You can come in here and choose just the edge function group and expose just those tools to the LLM. The ones that you don't choose won't even be shown at all. They will never have access. And actually, what you're looking at right here is what we're calling our URL builder. So this URL builder, this actually lives right in the dashboard. So if you go into the dashboard, that connect button at the top, and then the MCP tab on the right, you can use this to actually do some toggles like read-only mode, feature groups, and it'll actually build you a custom URL that you can copy and paste into your client. It'll also allow you to scope this directly to just a single project, so you can be confident that the MCP server is only interacting with a single project and not multiple projects. Okay, the next thing that we added is doc search. So probably if anyone here has worked with LLMs, I assume everybody, you know that one of the biggest challenges is knowledge cutoff, right? And one thing that I was actually surprised about on the early days, like back in 2023, was actually how good the LLMs still were with Supabase. Like they actually had pretty good knowledge even back then. They weren't amazing though. Fast forward till today, I'd say a lot of the LLMs, like the flagship ones, are like really great. Like they understand a lot of Supabase. But the problem is it's never going to be like fully up to date, right? There's always that knowledge cutoff, and it's not going to have the most up-to-date information. So let's say there's something that we launched literally, let's say today, and you want to start working with that immediately. Your LLM isn't going to have knowledge about that and won't know how to work with it. So to solve this, we created a tool called Search Docs, which gives you, under the hood, we created what we call our content API. It's actually a GraphQL-based API over our documentation that you can use to provide that to the LLM, and it can search over the docs for, basically, it's always up-to-date current information from our docs. Under the hood, we're also using a hybrid search approach. So if you've gone down like the rabbit hole of embeddings and keyword search, we're using that same technology from our docs for this tool. Okay, next is what we call advisors. So the challenge here is how do you know that the LLM is actually following best practices? Especially with MCP, you can connect this to any LLM. You can connect it to the best models out there, and you can connect it to local models on your machine that maybe aren't so good. So how do you know that these are actually producing like high quality SQL? And so the way to ground that is through what we call advisors. Advisors are actually something that already exists on top of Supabase, and you can think of them as like lints on top of your SQL. So looking for best practices, right now we have two types of advisors. One is performance advisors and one is security advisors. So it'll actually scan your database and look for things like, are you creating RLS policies? Are you following best practices on your database? And then in this example, you can see like, why is my query slow? And we're talking to ChatGPT, and so instead of ChatGPT giving me like a general, oh, your database might be slow because of this, this, and this, is literally looking directly at my database and saying, oh, you got this to-dos table, you're missing an index, here's what we can do to fix that. Okay, and finally, we added some initial support for storage. So we have storage buckets at Supabase, and so this just gives the LLM the ability to check which storage buckets exist and change some configuration. So it's basic to start, but we're looking to add more features like insight into actual files within your buckets and like analyzing the details on those. The cool one about the storage tools is this was actually a community contribution. So yeah, what I would say there is if you guys ever feel like there's a feature missing from the MCP server and you're like, this would be really great to have, like by all means, please create a pull request. We work in public, we work in the community, we're all working on the same code base, so please submit those. Okay, and then what's next for the future? There's three things I'm excited for what's next. Number one would be fine-grained permissions. So earlier I was talking about how we have the MCP auth, but you can see in this screenshot here that we have, you basically have to give it all or nothing, right? You give it read or write access to database, edge functions, storage, all that in one like binary decision. So where we want to go with this is each one of these should actually be a toggle that at this point in time you can choose exactly which ones you want to expose. So I mean, we already have feature groups that give you this capability, but this actually narrows it down to which features are available at the access token level. So like the most secure way possible to do that. Okay, next is local first. So like I said, super excited to support local MCP with the local stack. But I think there's a lot of more things we can do around this. Basically, we want to double down on this. This is something that I think there's lots of room for improvement, maybe some integration with the CLI. Just make that local dev experience first class with MCP. Okay, this last one, I know I keep on saying I'm excited. I'm excited about all these features. You might have asked, what about you? Like, what if you want to build your own MCP server on top of your existing apps and projects within Supabase? So I'm super stoked to share that we have on the roadmap, we're currently working right now on the ability for you yourself to also create an MCP server on your apps on top of Supabase. So we're basically using the playbook and the lessons learned as we built our own MCP that we just presented today, take all those learnings and we're gonna apply those to allow you to give you all the tools you need to build your own MCP, including MCP auth with all of the OAuth 2 protocol you need for your own project, and remote MCP support as well. All right, so do we have time for a demo, 2-minute demo? Yes, okay. I was hoping that maybe, we ran out of time. Okay, so here we go. So what I have here is LM Studio. Anybody used LM Studio before? Maybe? So there's Olama, there's LM Studio. What this does is this allows you to run models completely locally on your machine. So the reason why I wanted to demo this today is because I think it's like, now that we have local MCP support, I thought it'd be super cool to like do like a fully offline, like you could do this on an airplane kind of thing. A lot of airplanes have internet now, but you can't use that example, I guess. But you get the idea. So the first thing I'm going to do is I've actually already set up the MCP server, but I'll show you how that was set up. If I go into the details, it's just an mcp.json file. So what I've done is, I'm sure we're all familiar with this JSON file. Pretty much every client follows the same format. And unlike the old standard IO command, all it is a simple URL that you can pass into here. So I've already spun up a local Supabase stack using the start command. It's using the latest stable build. And I pop that into here. If I come back over here, you can see that it has now connected that, and you can see all the tools that are listed here. So first I can say something like, oh, actually, let me load the model first. That might be important. So I have GPT OSS, the 20 billion version. I'm going to load that one up right now. That was very quick, so it looks like we're good to go there. I've already added the MCP server as context here, and I'm just going to say, what tables do I have available? We had a failed tool call, but then it figured it out. Okay, so it's going to first list the tables to see what's available. This is very common with MCP, and we're saying, looks like you don't have any tables. That's what we expected. So please help me create a to-dos table. So these would be like a hello world type of app to-dos. This is like a classic thing that you do. Now, I'm going to say this right now from a security side, always read the SQL that it generates before you run it. I know a lot of you guys like to do like the YOLO modes. We do not recommend that. So please read what it's doing. Okay, we're creating a table, public to-dos, looks pretty good, pretty impressive from a local model, so let's go ahead and proceed. By the way, local models are like tool call capabilities in general with local models have been notoriously bad. So the fact that this is working with tool calls is, in my opinion, like amazing. So there's a new table. I can say, okay, great. Can you confirm by listing the tables? Let's just confirm that. Awesome, it found that. RLS is not enabled. So we could do that, but instead let's just quickly check what it has. Okay, so we have an ID column, title completed and created that. Let's add a category column. So we can track which category these to-dos belong to. It's going to apply a new migration. I didn't read it. I just blindly clicked it. Okay, whew. Simple command. We're good there. And then finally, we can say, can you show me which migrations I've run? So it's going to call this migrations. And we have our two migrations, one that created the to-dos table and one that added the category to-dos. So this happened completely offline using fully local Supabase and fully local LLMs. Awesome, thanks.
We love a live demo. Okay. Next to the stage, we have Tarek. Tarek is a group product manager at Snap. As you can see, he's wearing the spectacles. Very cool. And he's going to talk about some of the cool work they're doing and how they're using Supabase. So let's welcome him up.
Thank you, thank you.
I could show, but I don't have a lot of. Let me. Is it showing? Sorry. Hi everyone. My name is Tarek. I'm from Snap. I work on spectacles, and I'm really thrilled that we get a chance to talk to you guys about sort of like the glasses and AI. I think there's sort of like maybe like a secret that we feel we know that like no other people don't yet in some ways when thinking about sort of like AI and AR. So what I'm going to talk to you over the next little while is just sort of like the amazing ways you can use AI with the glasses. It'll give a hint at sort of like what we're working on with the Supabase team. Can't talk about it just yet. A couple more weeks, there'll be some really exciting announcements regarding that. But the one thing that I was going to take you through a very, very brief preview. Glasses has been a thing at Snap for the last decade or so. We kind of started with 2 different pairs of glasses that you could just camera glasses, and along the way we were like, you know what, let's just make the jump to a computer or a spatial computer that you can actually wear. And then the last one we released in September, the idea was to actually put the power of that spatial computer in the hands of developers like you, which is kind of like how we even got to learn about the amazing Supabase community and the care that's giving in sort of like building that developer experience. So when it comes to spectacles, I'll just kind of like give you a quick preview of the product. One interesting thing that we try to do with this product is to build a product that's truly standalone. The entire compute happens on device. Nothing goes to the cloud for rendering or any of those purposes. The way we achieve that is by basically distributing the compute through 2 SoCs. So there's actually 2 SoCs on each one of the sides of the glasses. And the reason for that is because heat. The interesting thing about glasses is that the more compute you run, the more heat you produce. Computers, if you remember back in the day, had like active cooling with fans and what have you, but with this kind of product, you cannot do that. You rely on basically the surface area and just having that heat exchange with the surrounding environment, which is not very fast. And the interesting thing is like people want it to be smaller. So you lose more of the surface area and they want it to do more. So you have to increase the compute at the same time trying to deal with the heat. It's a very complex set of trade-offs. I'd say one of the most amazing things about the way that we think about this product is just how we thoughtfully think about each and every single trade-off we have to make along the way. And sometimes those trade-offs are years into the future where certain things happen along the way. Which brings me to one of the most exciting things that has happened in the last 2 years. I personally have been working on glasses for the last decade at 3 different companies. And there's always this thing about augmented reality is like 2 things. Number one is that it augments your world, right? You can put things in the world. And then the other half was all about, people call it contextual computing. It's just the fact that a computer can actually understand what is going on in your world, the same way that you reason about it, right? That was an impossible problem in some ways because you could never kind of get it to do it just right. And lo and behold, 2 years ago, something came out of nowhere, multimodal LLMs, and suddenly the computers can kind of reason about the world in a very similar way that we do. And that unlocks something, I would say, like truly, like, I don't know, for someone like me personally, is like astounding what is now possible. And what we're going to talk about briefly is some of those things and why spectacles is particularly suited for anyone who's actually thinking about where is the terminal destination of AI in our lives. I reckon it's probably not just exchanges of text or even voice if you think about it, right? There's a bunch of dimensions that are missing. So we'll talk about spatial awareness, real-time custom object tracking, seamless voice input, 3D object generation, and spatial reasonings with LLMs. So with spectacles, when you actually use the product, the entire experience is actually grounded in the world in front of you. Objects interact with your environment. They can be anchored to different things around the world you're in, and you're basically able to interact with them. That actually adds this sense of realism, blending sort of like what you do physically with what you're doing digitally, right? As you can see here, this is an example where somebody's using a drum set, and they're able to get feedback in real time about how they're playing the drums and help them get better. One that I'm particularly excited about is this idea of real-time object tracking, particularly for custom objects. So it's not just about recognizing there's an object in the scene, but actually being able to track it in real time and understand what you're doing with it. With that, you can basically turn any physical object into a controller for a digital experience. You can see here on the left, example is basically tracking the chess pieces and understanding what you're doing. You're just kind of like doing chess, right? Which is kind of like the magic of AR glasses in general, is that you're just doing what you do. And with augmented reality, it's kind of just complementing what you're doing rather than replacing it. Same with the piano here. I used to not know how to play piano. I still don't know, but at least I can play a song. And that was just basically through this process of just like watching, playing the piano and getting that aid directly in my field of view versus looking down on my phone or an iPad or something, what have you. Same thing applies to pool, like that example in the bottom left, as well as the basketball example here, where it's kind of fascinating that the glasses are actually tracking that ball in real time and recognizing that it actually entered the net and just updating the score. Again, it's not like actually changing the experience of playing basketball. It's just augmenting it. And I think this is just the beginning, especially now where there's a lot of exciting ways that you can turn these. So these object trackers run on device using a feature we call SnapML, where you can deploy them and you can actually understand what your users are doing. Over the last little while, we also added a lot of support for recognizing what you're saying through LLMs. I think it's a well understood concept, and it powers already a lot of experiences like translation and all those standard use cases. And I think the interesting thing about everything you see here, those are all built using the same tools that we make available to developers. We have a rule internally that we don't use internal APIs as much. We build with the same APIs that we make available to our developers, because that's how we maintain a level of developer experience that at least matches our own expectations. Another interesting thing that you can do with the glasses is they provide you with access to the camera, so you can actually generate 3D objects that can keep your experience fresh and actually more responsive to the interactions that you're doing in the real world. There's an example here where one of the lenses that we call Imagine Together, where you can basically imagine objects and they get generated. 3D objects get generated in real time. And this is actually a multiplayer experience, so there's actually multiple people experiencing that, and they can kind of pass these objects to each other. This feature is the one that I'm most excited about. I think it's just like shows sort of the magic of like when you combine that multimodal capabilities. So you can, for example, send in a camera frame to an LLM. The LLMs of today can actually reason about like what's in the image. They'll spit back at you a coordinate in that image, an XY coordinate. But when you send that original image, I might be looking at the gentleman over there wearing the black attire there. And by the time it goes to the LLM, let's say, for example, which person is wearing the black attire, I might have looked that way. But I need the annotation to be on that person. So it's able to go back in time and actually match that, and you don't have to do much as a developer. That is done for you. So that you can start to begin to understand sort of like what becomes possible. It becomes sort of like a situation where the AI's output sometimes might be even very subtly changing what's around you and showing you a different version of how you experience the world. See a bunch of examples here. This dinosaur example is my favorite, where it's able to show you sort of the different bones, as well as fixing your car or learning about plants or what have you. So one big question that comes up when looking at all this power that these types of experiences have, particularly with a product like this, with cameras that can see what you see, hear what you hear, is a big question about privacy and how you handle that. There's not a lot I can share about that, but this is part of the reason, for example, we're thinking about some of those things. How do you build infrastructure that's privacy first? There'll be more to share about that into the future, but I think it's just keeping in mind that with all this power that with AI and the access it has to a product like this, where the data goes and where it lives becomes a pretty important question. Last but not least, we are going to be here tomorrow. The team is here. They brought a lot of devices. We love hackathons. We go all around the country at universities and run hackathons, so it's just like kind of like our jam. The team told us here that they're running a hackathon. We're like, perfect. We brought in the glasses. We brought in our team that basically cycles through these hackathons, and we're ready to help out. But in order to build on those glasses, you're going to have to use Lens Studio. I just was going to mention for all of you what's awesome about Lens Studio, so I'll do it really quickly to be respectful of time. Number one, it has a built-in simulator, so you're actually able to try whatever you're building right away. When you're building these types of spatial experiences, you really have to feel it. So a lot of the time, you really need to push it to the glasses to experience what it's like in the real world. Because we don't compile the code, it's TypeScript based, we are able to actually push to the glasses right away without waiting for a couple minutes for the code to compile and then for you to actually put it on the device. So that makes your workflow, which is probably the most impactful thing, because this medium is still so new that it's kind of hard to know like what actually feels right. There's a lot of iterations that you have to go through as a developer to actually appreciate how to place this content or how to design your interactions. Within the simulator itself, we also support hot launching, hot reload. So it will, as you're making changes, it'll automatically reflect in your preview. The preview has basically representations of real life scenarios as well, like walking on the boardwalk or what have you. So it's able to give you a sense, at least as you're developing, of what the experience would be like of someone wearing the glasses. We also offer an asset library that has a lot of free assets to help you get started. It also has some helpers that might help you sort of like attach certain behaviors to your experience. We recently also added TypeScript support because we thought there's like the complexity of these experiences is increasing. Teams want to work together and just want to have a better handle on like how to exchange code amongst each other without having to reason about like how somebody might have written their code. And last but not least, we have like a handful of SDKs that are specific for spectacles. So we have something called the interaction kit that helps you add interactions to your UIs. We have a UI kit that has a bunch of the UIs that are common in the system. They use the system design language. So if you don't want to reinvent everything, containers, those types of behaviors, how you resize things, as well as a navigation kit that can help you create guided navigation experiences in certain locations if that's what you would want to do. And we have many more planned. Actually, in 2 weeks, we'll probably be announcing a bunch of more that basically help accelerate the development experience. So a couple thoughts I'll leave you with is please check them out. We are in at the entrance of the other building. Team would be happy to give you a demo. Join our Reddit, Reddit/r/spectacles. You can get a glimpse of sort of like what everyone else is building, what type of questions, what are they doing with this. And last but not least, if you are a developer, you're excited about trying this, apply. You can download the Spectacles app. We're currently only making this product available to developers. And next year, we will be launching our Specs 2026, which is our first consumer version of this. All I can say, it's much smaller, and it is even bigger field of view, and lots of exciting stuff that will start sharing with you all. So if you want to build for that future, please stop by, and we're happy to answer any questions you may have. And once again, thanks to the Supabase team for having us here. We're super thrilled to work with them, and I think there's going to be a lot of great things that are going to come out of this in the future. So thank you so much.
Okay. I think we have a 5-minute break before the next speaker, or we might roll into it. But we have my friend Zeno, who is the founder and CEO of Resend. He's going to talk about building a developer-led company and working with a bunch of developers and building on top of Supabase. So Zeno, excited to hear you speak.
Hey everyone, how are you doing? Good. How are you feeling? Nice. I'm super excited to talk to you today about how to build a developer-first startup. But why even build for developers, right? Why is this a good idea in the first place? I think for many of us, when we started our careers, we used to be able to influence purchase decisions, but not necessarily authorize them, which is no longer the case. Developers have way more influence in the process of purchasing software overall, right? Used to be the case where top-down, like, would come in, the execs would tell exactly, hey, here's what you need to use, and then you just go and execute that. Today, there's way more ownership. You go in, you're able to input on the decision, or even just swipe the credit card and start using things like Supabase. And this evolution of developer tools, I came up with these different generations, but you could tell there's like a difference at every single one of these points. In the beginning, developer tools were nice to have. They were beautiful because they enabled collaboration, but it wasn't a thing that everyone would use, right? You had companies like JetBrains or Twilio or GitHub starting up or Cloudflare starting up, and those are great, but not everyone had access to them. Then the second wave came in, and now it was much cheaper. Now everything was API-driven, and it started to become this mission-critical workload that you couldn't just survive without it. Auth0 came in, Algolia, Stripe, Elastic, and so many others. Then the third generation came in, and now things started to become even more seriously, and it was just so easy to integrate. Everything was plug and play, right? If you wanted to use Retool, you just get started, you're done. Netlify, Vercel, all of these companies, they opened the door to something that was really magical. And I feel like we're living through this next generation, and there's just some things about this next generation that I feel like are really unique. The first one is the time to market. I think we can all build stuff much faster than we could before. And it's not like the world is API first anymore. I truly believe we're living in an SDK first world, which means we're able to get things that are tailored to the ecosystems and platforms and languages that we all love. And there's one characteristic across all of these different products. They're all obsessed with developer happiness. You go to Clerk, you go to LiveBlocks, you go to Rayaway, you go to WorkOS, Mintlify, BrowserBase, you go to Resend. It feels like that was built for you versus someone else. But how do you even go about creating developer happiness? Like, how do you even approach it? I separated like a few ideas and the things I believe make that happen. So the first thing is to focus on one feature, just one crucial core use case. I remember when I first went to buy my first car, and that was a pretty interesting experience because I remember driving through the streets of LA and trying to find a place to park. And then I saw those signs of like, oh my gosh, I don't even know, like, can I park or not? Like, what's really happening here? So everything was like so confusing. There's just so many rules for me to process. And there's actually like a UX principle behind that. There's this Hicks law that says that the time it takes for you to make a decision increases with the number and the complexity of the choices. So the more options you have, the longer your reaction time will be. So it's no surprise that when you go to a product like Azure, you're like overwhelmed with options. There's just so much stuff happening, right? And that's true for all the major cloud providers, right? There's just so much happening. Heroku did something beautiful when they were launching their buttons marketplace, that you would just go, even though there are many options, you could just come in. If you just want to deploy Ghost, for example, you click in one button, you follow the steps, and you're done. You're in production. So that kind of experience makes something really special. I remember as a developer myself, I wanted to just send an email. That was my mentality. I would go to SendGrid, I would go to Mailgun, Postmark, and I'm like, I just need to find this one API. I just want to send an email, and I couldn't. It was just so much complexity around me. So that's when we're like, okay, what if we could just build one email API as simple as possible? You can just send with React. Let's see how it goes. And that's how we started Resend, just focusing on one core principle and not just an overwhelming amount of options. The second part is about this builder versus user dilemma, right? Because when we're building something, sometimes as a user, I went to the dentist, and as a buyer, I actually feel like going to the dentist is a great idea, right? It's good for your health, it's amazing, I'm happy to pay a dentist. But as a user, I absolutely hate it. And that's the difference, right? With buyers, the things that they see and the things that they care are most of the times completely different from what users actually perceive and what users actually care. I'm reminded about this story that happened in LA where the school district purchased $1.3 billion on UiPads. And then later on, they found out that only one teacher out of like 200 plus classrooms was using them. So this is where the conflict between what the buyers really care and what the users really care happens. I remember going to the Prisma website, and it was so beautiful, this previous website they had, where they only had 2 call to actions: npm install, try in 5 minutes, right? As a developer, I feel at home in that kind of environment. In contrast, you go to a place like HashiCorp, and you have read customer story, request a demo, contact sales. Like, that's not the flow that will take me from 0 to 1. This is a flow that will probably take me weeks or months to get from 0 to 1. Same happened when I was just trying out, like, okay, let me go to Mailgun, and there's a schedule a demo button, and you have to go through that flow. Or you say, you know what, let me just sign up for myself, and then there's a payment or a credit card flow, and I would have to fill out all these forms. These are things that take the users away from just getting started, right? When we're building the Resend website, we're like, okay, what are the little things we can do to show that we care, show that this is for you as a product? So when you go to the website today, you can open it right now. We have this call to action, integrate. Depending on the time, it's going to show integrate this morning, integrate this afternoon, or integrate tonight. And if it's past Friday, 5 p.m., it's integrate this weekend. So just a very little thing, probably no one cares, and no one will notice that the light in the button actually changes depending of the time, right? These are details that just send a hidden message that this is for you. One other extremely silly thing we did was on the dashboard, you go in, you have a sidebar, the icons will be animated. That was so silly, and everyone would tell us like, oh, this is awesome, I can tell you guys care. So that's the difference of a product that as you are building something, that you have like those small surprises, that adds up. That adds up to a product that people love, that they praise, that they will tell their friends about it. And the opposite is also true, right? When you go to a product and the CTA is not clear, and you finally sign up, and then you don't get the email. It takes 5 minutes to confirm your account. And then you go through the onboarding, it doesn't work. You go to the docs, there's a typo. That's a product that you're not going to trust, that you're going to churn, or the worst that it can happen for any brand is a product that you're going to be indifferent to. That's the worst thing you could have. It's better to have people hating your brand than not caring about our brand. So there are products that are very well known for being sales-led, right? Like Jira, for example. Everyone loves to hate on Jira and tell how like, oh, this is so bad, and so on. And then there are products that are product-led that people love it. Notion, Linear, they praise for how they care about the users, right? So you have this dilemma. One is not inherently better than the other, right? I'm sure folks at Atlassian are not complaining about the revenue. But at the same time, it's a matter of like, what is the company you want to build? What is the product that's best for you as a founder too, the things you feel connected to? The other part is about being open source friendly. And I want to tell you my story with open source. My first open source project was called jQuery Boilerplate. Anyone remembers jQuery here? Do you know what that even is? Okay, great. This was a way for you to create jQuery plugins. Then I launched it, and then Smashing Magazine picked it up, and they tweeted, and people started to know about the project. So I was like, oh my gosh, this is crazy. People are like opening issues, and I was so excited, like, oh my gosh, I built something that people actually care. And then I got this pull request saying, everything is wrong, so delete all of it. This way you can start over and do it again. You can imagine how I felt when I got that PR. I was like, whoa, what's happening? This is crazy. This person who opened the PR was super influential in the JavaScript community back then, so I didn't know what to do. Eventually, my friend, Adi Osmani, got together with me. We started like rebuilding. I actually accepted this PR. And yeah, the diff, if you open the diff, like it was just removing all the files and deleting everything. But you know, sometimes the open source community can be rough. Steve Ballmer is famous for saying that Linux is a cancer that attaches to everything it touches and so on. Which is funny enough, right? Coming from a Microsoft CEO and looking at what Microsoft is doing now. There's VS Code, who was built by Microsoft. There's GitHub, built by Microsoft. NPM was acquired by Microsoft. And Microsoft, if you think about it, owns the most popular code editor, the biggest package manager. All of our NPM packages are running there, and the largest code repo and code community. So the game flips, and you can tell like how crucial a strong open source strategy is for companies of all sizes. You go to Vercel, of course, there's Next.js. That's the biggest thing that they anchor. But they have plenty of open source projects on top of that. When we started, that was our thing. Like, we're not going to be open source, but we're going to have an open source component. And we built React Email, which was this library of components that were pre-made, that were beautiful for you to just get started building email templates, because emails are super hard. Even today, if you want to build like a rounded corner button that doesn't work on Outlook and Gmail and Yahoo Mail the same. So we built React Email to solve that problem. And that was our master plan. I remember just writing that Notion doc with those three things when we started. Build an open source project related to email. That was React Email. Gain traction and respect in that ecosystem. Launch a SaaS to help people to send emails using React. And that was Resend. So highly recommend thinking about how you can layer open source on top of everything that you do. And then once you do that, how can you be embedded into the open source ecosystem? So for every single language, we have examples for every single framework and every variation of that framework even. So the more you can be embedded and have like GitHub repos for each one of those things, the better. Now, charging is also important. And for us as developers, that's not something that comes natural. Another story, I remember traveling a lot when I was younger. And I remember traveling from Germany to Spain one day. And I started to feel really sick in the plane. I'm like, oh man, what's happening? Like, there's something going wrong in my body. I was alone. And then at some point, I was feeling so much pain that I just had to call the flight attendant. I was like, hey, can you just, I just need help. So then they landed in Madrid. I was taken in an ambulance out of the airplane. And then they take me to the hospital. So I'm like, okay, this is crazy, but in 2 hours I'll be better, and then I'll leave, and it's fine. Turns out I spent 3 weeks in that hospital, and that was a crazy experience, right? But the craziest part wasn't just staying in a hospital in a foreign country. The craziest part was one day I told my coworkers, hey, I'm here, don't have anything to do. Can you just bring my laptop so I can do something, talk to my family, do some work? And then they bring my laptop, and then I'm just like coding, I'm happy again, this is fine. Then one day I leave the room just for a second, then I get back, my computer was stolen. Someone entered the hospital room, took the computer, and went off. I was like super sad. Oh my gosh, this is the worst thing a human being can do. But then I call again my coworker and I say, hey, can you bring a new computer? This is what happened. And I know it sucks, but hey, I need to talk to my family and so on. And then I do what every developer does when they get a new computer. I'm setting up my code editor, and I'm like, you know what? Doesn't make sense to have like different themes in different code editors, so let me create mine. So I created this thing called Dracula. Does anyone know what Dracula is? Oh, nice. So I built for Sublime Text, for Hyper, for iTerm, Hyper didn't exist, for Vim, and so on. And Dracula now has like 400 something themes. So there are ports for every single editor you can imagine. Only on VS Code, there are 9.4 million installs. I never imagined that a project created in a hospital would lead to such thing. But I remember when I saw Dracula growing, I was like, hey, this is a great opportunity for me to learn more. And I want to learn more about sales and business and so on. So let me try to sell this, which is super hard to sell like 5 or 6 colors, right? But I was like, let me see if I can create Dracula Pro. That's how I position. Dracula Pro, this package with these different themes that you can use and so on. And I just launched it to see what will that do. Dracula sold, I just got that screenshot. It sold more than $400,000. This package of colors that you can go install on your cursor and your code editor. To me, that's absolutely wild to see a side project doing that impact, but it just shows the power of charging, because through charging, you get to learn exactly what people want versus guessing what's really important to users. So I highly recommend, if you're building anything, charging is the way to find the truth, which is hard to get. The other part is about integrating. So I don't know if the audio is going to work, but there's this quote from Bruce Lee, super famous, you've probably seen before, but let's play and see if we can hear it. Right? It's okay, no worries. But it talks about like being shapeless and formless and be like water. That's how you want your product to be like water, to adapt to whatever the ecosystem wants. Stripe did a great job with like adding a Stripe experience inside the code editor, where you could try the webhooks and trigger test charges and so on. They know that you're already in the code editor, so why not build an experience that's native to that? Supabase did an amazing job when they came up with the type generation. So you would get your database, and then it generates the whole TypeScript schema for you. This is just amazing, right? Same for the OpenAPI spec. A lot of companies these days, they offer like Postman collections for your API. So again, you're already using Postman, so why not just have all of your endpoints in the same place? So there's this, the Jacob's law, which tells that users will transfer the expectations they have built around one product to the other. So you want to leverage that to your benefit. So if you're building a developer tool, like imitating some of the UX patterns that GitHub has, for example, it's a good idea. Users are already used to the concept of PRs and organization. So you want to lean on those concepts. I remember when Supabase was essentially like changing the limits and changing how they would operate with their SMTP server, and how they were like struggling with all these abusers coming in and trying to take advantage of that. I saw that and I was like, wow, this is great. Let's see if we can help them. Let's build integrations, a marketplace thing with Supabase. So went ahead, built that for 2 weeks, and we just created this flow inside Resend where you connect with Supabase, it goes through the OAuth flow, and then you just choose all your Supabase projects, and then you can go and then add an API key that's associated with your project. And then once you have that API key, you're ready to configure like your sender name and you're good to go. You configure SMTP in like 30 seconds using Supabase and Resend. When I was building that, because the whole team was busy and there was no one to build those things, Supabase was coming up. I remember building that feature myself, and I was like, oh, okay, this is cool, but maybe 100 people will use, I don't know. Eventually, Paul started to promote and talk about it too, and recommend Resend as a SMTP provider. And I was just chatting with the team recently, and they said that of all the active Supabase projects that have custom SMTP, 39% of them use Resend. This was a project that was just like one of the bets that you do when you're building something new, and it was a bet that played out because we were integrating with others. So I highly recommend whatever you're building to think about what are the integrations that I can do and leverage that for you to grow. And generating momentum is a big part of building a startup, because what you want to do is to keep the machine going. When we're just coming out of YC, I remember being very afraid of opening this product to everyone. So we had a wait list, and we were just onboarding people every week. So we had about like 140 new signups every week. And I was happy with that. I was learning from those 100 people coming in every week. And then our YC partner, Diana, she said, hey, Zeno, you're moving too slow. This is not going to work. Like, you got to figure something better. So we're like, OK, let's open this to everyone. So we announced it that, hey, now this is open to everyone, and you can just start using Resend. And from that point on, this is a chart from 2023 to, just 2023, actually. And the difference from the moment we were just like behind a wait list to the moment where we opened to the public. So the reality is that if you're building something, you just gotta put whatever you're building in the hands of users sooner than you think. If you think like, oh, I have to build this one thing for next month, how can you make it the next 3 weeks or the next 2 weeks or tomorrow? What would it take to launch it tomorrow? How can you make that happen? And once you start going through these thought exercises, you're going to be surprised by the amount of things and the amount of scope you can actually cut to deliver things to users. I love this tweet from Kenneth. He talks about how for startups, momentum is key. And that's the beauty of building a startup, right? Like if you just go through a linear path, you're probably not going to get there. But with momentum, you can actually do something. For me, the best analogy for that is a heartbeat. So if you're building a startup, you want to have like small bumps to show that you're alive. And then every day you're posting on Twitter. And then every week you're launching a change log. Every 2 weeks you're launching a customer story. Every 3 months you're doing a launch week. Those are the big peaks. And that's what keeps you alive. Those are the things that they compound those activities. Of course, there's no one better than Supabase when it comes to launch weeks. I shouldn't be talking about it here. They know better than anyone. They really promoted that concept, and there's so many launch weeks happening now. And we did our first one in 2023, and we saw the impact, not only externally, but internally. Because when you have a date and you're pushing the team towards a launch, it just rallies everyone to that same goal. And we kept learning, iterating. We built like, okay, now let's create these fancy landing pages to promote these launches. And let's compare the difference between the first one and the second one. What did well, what didn't? And here are just some of the learnings. We ran like 4 launch weeks already, and we're doing the 5th one in a month. And we learned that anticipation is key, because if you're trying to build something to the public, you want everyone to be engaged and like looking forward to that moment. You also want to set the tone that, okay, this is going to be big. So your first day, if it's a week launch, then people will know the rest will be weak. Today, if you just do a launch week and it's the same as everyone else, no one will care. So it has to be visually appealing, or it has to have a story behind it. And you should definitely lean with strong announcements. If you don't have a strong thing to talk about, it's better not even to do it. I love this heartbeat analogy because Tyler has this amazing quote. He says that if you consider how impossible the startup journey is, and it's really impossible, it's really insane if you think about it, it stands to reason that only through intensity can something be created out of thin air that grows to be worth billions of dollars in just a few years. Startups are dead by default. So if that's true, if startups are dead by default, you gotta find a way, you gotta funnel the energy somehow to create that momentum. And then being developer obsessed, that's the other thing too. I don't know if you all are familiar with this documentary, super popular here in Silicon Valley, so you probably already know. It's called Jiro Dreams of Sushi, and it's about this sushi master that has a 3-star Michelin restaurant, and he started working from the age of 7. And it's really intense when you go through his journey, because even at age 85, when he's recording the documentary, he talks about how he still haven't found and achieved perfection. But that's the journey. Yeah, you're always building towards that. But even after making sushi for like 60 years or more, you still haven't found that. So when you think about what you're building, right, think about all the pieces that goes into it. You can build something that works, like a design that works. You go to Braintree, for example. It works. It's a website like any other. I'm sure there's a lot of people using their API. But you can do design that actually inspires people. And that's what you get when you go to Stripe, right? You go to their website. The first thing you feel is like, wow, I wish I could build something as good as this, or let me try to build something great as Stripe did. There's changelog that works. You go to most companies' changelog, you see the changes. It serves the purpose, right? This is a changelog. It communicates that. But can you do a changelog that inspires? That's what you get when you go to Raycast's changelog. Not only it's visually appealing, there's a lot of momentum, but you see that the team is actually shipping stuff and making the product better every single week. There's recruiting that works. You go to any careers page in any website like PayPal, you see all the roles, you apply, no big deal, right? That's the status quo. But there's recruiting that inspires. You go to Plaid, they used to have this, they don't have it anymore, but you could apply by an API call. How cool is that, to submit your resume in a post request? That's really awesome. So there's this concept that users will often perceive aesthetically pleasing design as design that's more usable. So it's no coincidence. You go to Stripe, you go to Vercel, you go to Raycast, hopefully you go to Resend, and you feel like, wow, there's so much care in the design. I imagine all the other things they do on the back end, because there's just so much care here. So this is a strategy. This is not an accident. There's this Maslow hierarchy of needs that's super popular that talks about the different needs that a human has, right? Starts with the physiological needs, safety, belonging. So the bottom of the pyramid is like, you need food, water, and sleep. Those are the basic things you need as a human. Then there's safety, housing, financial safety. Once you feel, that you have those things, now you can start thinking about belonging and thinking about friends, relationship, community, how those things are in place. Then the esteem in your community, how you're treated by others, respected by others. And then once you achieve those things, now you're at peace. Now you can innovate. Now you can actually do new things. I actually believe there's a developer experience version of this too, that starts with the functionality, the base thing. If you don't have a REST API, if you're not returning your objects in JSON instead of XML, or like if you're not following the basic protocols and the basic functionality, then like you don't have the basis. You have the functionality, but the API is down, or the API takes like 2 seconds to return. That's also not ideal. So you need that foundation really strong. Then you can start thinking about docs and SDKs and demos and change logs. How can you make them great? Then you move up to the CLI. You think about OpenAPI specs, your webhooks, versioning for webhooks. And then you get to the point where like, okay, how can we be creative? How can we offer something different? And if you're building a developer first startup, and if you ever settle, you're just doing it wrong, because building for builders is probably one of the hardest things you can do, regardless of who you're building to. And then the last thing is just focusing on what you can control. There's really nothing you can do outside of what's in front of you. So I'd like to tell you a story that happened early 2024. Resend was growing up. People were starting to use Resend more. And the team was very, very small. We had like 6 people or something. The team was really, really small. But we already had a lot of production load. So then one night, my co-founder calls me. This was like around 9 p.m. And he said like, oh, I'm running a migration script and so on. So he just started running that migration script, and then suddenly we were like, oh, what happened? We were building this, and then the production database started to become empty. So we're like, oh, okay, there's something happening here. And then he calls me, we're like, okay, let's figure out what's going on together. What is this thing happening? So we're like, no worries. We're using Supabase, they have backups, we're good. So we go, we're like desperate, so we just go super fast to the UI, we select the latest backup, and we click restore. Like, okay, we're good, we're safe. Now let's just wait for the restore. We announce it on Twitter, we open a status page, we talk about the incident, and then people start noticing the incident. So they started to tell us like, hey, this is impacting us super badly, I'm already moving to someone else. And we're like super sad that this is happening, but you know, now we're just in this waiting mode and replying mode on support and social. So from the moment, this was like 10 p.m., the moment we started to restore, we just kept waiting. So then 1 hour later, still restoring. 2 hours later, still restoring. Keep in mind, we had like multiple terabytes of data in this database. Then 6 hours later, finally, it's back. We are super stressed. Everyone is like just super mad at us. 6 hours outage. This is unbelievable. This is crazy. So disappointing. I'm migrating. And we're like, okay, at least we're back after 6 hours. And then I go to the website, I go to the database, still offline. What's happening? We go, and then we're talking to the team, and then we figure out the moment the database was, the migration script ran, there was another snapshot of a backup. And vacuum, for those who know Postgres here, vacuum didn't run, so the database was still the same size. But we restored an empty database. That moment, I was like, this is the worst time of my life. I just want to cry. This is the worst thing ever. But we just got to, you know, try to go online again. So we go to the other backup, not the latest that was empty, the other backup, and we restore again. So then, hopefully the Supabase team helped us like really speed up that one, but still 12 hours later we were back. So everything was normal, but people were like, this is the end of Resend. This is it. Yeah, there's nothing else. And that's how I felt back then. I was like, yeah, this was great. What a run. 1 year. We made it. But now let's just go back home, and that's it. That moment, we felt like this is the worst thing that could possibly happen. But just like with software, like you have your package, your little world, and these are the things you can control. There are all these other things that you can't. And we just tried to focus on what we could control. So we were a very, very small team, and then we just kept, you know, leveling up, growing. The team was growing, hiring great people. Now we're almost like 30 people, and it just feels unbelievable to even have a booth here, to have like so many people coming to us and saying, hey, I use Supabase and Resend together, and it's just great. And every day, that's what we try to do, just 1% better every single day, which is all we could do. Just recently, we crossed 500,000 users, which feels unbelievable. I know that because when I go to my Supabase off page, and I can tell like now more than 800,000 users using Resend. Warner Brothers, HBO Max, Raycast, Fall AI, Decathlon, Gumroad, logos that I absolutely love as a consumer myself are using Resend. A24, my favorite movie studio, is using Resend. Last year, we raised $18 million, our Series A. And when I look back, I'm like, man, that could have been the end of it. Or even before, we could have not even started this. But that moment just taught me, like, all you got to do is keep moving on, right? And we could have just not started Resend. We could have just said, like, yeah, these are the options that the market has. No one needs a new email API, right? But we felt that there was something there, something new. And we could have started tomorrow. We could have started next week. But what I would recommend to you is, like, start now or tomorrow at the hackathon, if anything. So I hope this was helpful. And yeah, thank you so much.
That was awesome. Thank you, Zeno. Next, we have another Supabase speaker. We have Inian, who is the head of product. I'm told don't mess with Inian, and he's going to be talking about security, so you definitely want to stick around.
Hey everyone, welcome to the security section of the talk. I'm Inian, I'm head of product at Supabase. I've been with the company for more than 5 years, and yeah, here to talk about how you can build secure apps with the primitives that you get with Supabase and some of the security related features that we have released recently, how people are building business critical applications, healthcare data, and storing all of that on Supabase in a secure way. So before I go into the security section of the talk itself, like, the community has been a big part of what we do at the company. You help us prioritize stuff, you help us build stuff, and you also help keep the platform secure. Since last year, we have launched a vulnerability disclosure program in HackerOne, and we've received 187 reports just this year from 131 different hackers, and that's pretty cool that people are also helping keep Supabase secure. And a big part of this is also the amount of stuff that we open source. Like, what we put out in the open source is exactly what we run internally, which makes it easy to test how stuff works under the hood, which if you're a security researcher, you just love. And when it comes to principles on how we think about security at Supabase, There are two main ways we think about it. The first is that the data is yours. It's your data. You control how data flows, especially with all the new AI features that we have been launching with, like, say, the AI assistant in the dashboard, where you can query data from your database and stuff. The default is that there's no data from your database that's being shared into the assistant. And if you explicitly opt in, you can choose to share just the schema, or like you can share just the logs, or you can share the actual data in your database if you're just prototyping something and you want to get information about, like, hey, I'm trying to implement Supabase auth and I'm getting an error, and the assistant can actually look at the logs to help you figure out what's wrong. And so, but again, if it's a production product, you may not want to do that, and that's totally fine. The second feature that is in early access right now is we are working with a few customers on bring your own cloud. So it's still the same Supabase experience, but the data is actually stored within your own cloud environment. And the advantage is that you get to, the data doesn't leave your security perimeter. You encrypt the data with the keys that you control, and that simplifies the security posture for some of our clients. And if you're actually storing healthcare data at Supabase, there is strict compliance requirements usually attached to healthcare data. And now you can mark projects that say, hey, this project has healthcare data, and we help you do the right thing by making sure that you can't disable point-in-time recovery, even if you want to, or you have MFA enforced at the org for these kind of orgs. And we make it easy for you to do the right thing. And the second principle that we have is, like, it's your data, so what's our role at Supabase in that sense? And we like to think ourselves as data custodians. You're trusting us with your data, so it's our job to make it secure. And this flows through every single decision and product decision that we take at the company. Even when you submit a support ticket, by default, the support agent cannot access the data in your database unless you explicitly give us permission to do so. And since it's your data, we also make it very easy to export the data out. Your database, your storage objects, whatever it is, you can self-host it, take it to a different provider. And that's because we think it's important to understand that it's your data and we are just the custodians of it. And when it comes to all the security features that we have built, we try to think of it in the lens of like a shared responsibility model. There are some things that we as Supabase are in charge of. We operate and secure parts of the platform. And there are some things you are responsible as the developer building on top of Supabase. And there are some things where it's a shared responsibility where you use the primitives that we provide to make your app more secure. So at Supabase, so what are the things that we handle for you? So any part of the stack that we think you as application developers shouldn't care about, stuff like how do I keep the operating system up to date? Is all the latest security patches applied? Is there a CVE in a Postgres extension that's been released that I need to update the database with? Is the data encrypted at rest? Is it encrypted at transit? What cipher protocols is it using? Is our packages that we publish for our client libs, does it have attestation properly to prevent supply chain attacks? There's just like a bunch of these stuff that we obsess over daily, so that any Supabase project that you launch comes with this very good set of default encryption methods and security built in, so that you don't need to think about, hey, have I taken care of all of this? And we do our SOC 2 and HIPAA audits regularly, and every year we get absolutely no exceptions to any of our controls. And this is because this is just so ingrained in our culture that, hey, this is not our data. We are trying to protect data of our users, and that seeps into every decision that we take as a company. The other parts of security is a bit more challenging, where it comes to like how easy it is for us to secure stuff versus how much capability that we give you as developers. So it's obviously super easy to say, hey, here's a box which does nothing, and it's obviously going to be secure, but it's also useless at that point. So what we try to do is try to balance the capabilities that we give you as developers with the security of the platform. And that sometimes involves building some new stuff. So I'll give you 3 examples of this. So the first one is, this is one of my favorite features at Supabase, is where you have the metadata of all your, say, auth users or like your storage objects right within your database. And that makes it very easy to query your database to just get information like how many users signed up yesterday, for example. And we found people writing triggers and like some custom logic inside these protected schemas that we manage. But the problem happens when we want to roll out, say, there is a security update that we need to do, and we need to roll out a new version of auth. Sometimes what happens is that the code that the user writes conflicts with our own migrations, and we are not able to roll out updates safely to users. And that obviously is not ideal, especially if it's a security issue, and we can't arbitrarily drop stuff that you wrote as well. So we need to work with the developer, and like that obviously wasn't scalable to rolling out fixes. So what we had to do was to lock down these internal schemas so that this is not possible anymore. But at the same time, we want to cater to the use cases that people had on what they were adding triggers to the internal schema, for example. So one of the things that we did to mitigate this was introduce something called auth hooks, because one of the main use cases we found people adding triggers for was they want to send an email when a user signs up, or they want to sync a different table with the information in the user schema. So now we just support this natively so that you don't need to write a trigger to do it. You can write a Postgres function or a HTTP API to run when certain actions happen in the lifecycle of an auth user. So with this, we were able to both achieve our security requirements of keeping the data schema to what we expect, and at the same time solving problems that you had with this new feature that we implemented. The second thing that we did is that the number of extensions that we had, like people always want more extensions bundled in. With Supabase, we have more than 60 extensions already. And one of the things that makes Postgres cool is the number of rich extension ecosystem that it has. But it also is a security maintenance effort for us to make sure that each one of those extensions are patched, each one has an upgrade path to, say, like a new Postgres version. Each one plays well with each other. So all of these things meant that anytime we had to release a new version of Postgres or a new extension version, all of this was pretty complicated for us to do. And over the last year and a half, I think, we've started moving our image builds for Postgres to use Nix. So if you haven't heard of Nix before, it's a functional package and a build system where if you give the same set of inputs, like the code, the compiler, and the dependencies, you get exactly the same output every single time. And using this, what it let us do was that it let us write automated tests much more easily. It let us build a bill of materials much more easily, because we know exactly which package, which version was going in for every single image that we released. And that made audits easier, running security analysis easier, making testing easier. And that brought down the time to release a new extension, for example, from a matter of months to just days. And we still have a bunch of updates here that would make it even faster. And all of this is also open source. Like, we publish the exact way in which we build our Postgres image that runs in production. And you can check out the exact logic for it in our Postgres repo. The second way which we let users bring in more extensions without compromising security is via this framework called TLE. So TLE is Trusted Language Extensions, which is a framework or an SDK that AWS came up with. And using this, you are able to write extensions in a trusted language within Postgres. So extensions in Postgres usually have pretty wide access, like they can read and write to files. And so we need to be very careful about what extensions we bundle in. But with trusted language extensions, because of the security boundary, and we know it's a trusted language and that plays well with the existing security model of Postgres, we can let users bring in their own extensions if required. And again, to make this actually usable, we built an entire package manager to bring in extensions into the Supabase ecosystem called database.build. And you can use any of the extensions built by the community or bring in extensions from that you have into your Supabase projects. And the other way we do this is with foreign data wrappers that can be built via WASM. So we have built our own foreign data wrapper framework called wrappers that you might have heard of, where you can bring in data from like Notion and a bunch of other third-party tools into your Supabase database. And if you have a tool that we didn't support, now you can just write that as a WASM module. And because for both TLE and WASM, we know what the security boundary is and we know how to reason about its security, we can let users bring in their own extensions. So again, this is an example of how we have to do some more engineering work to make sure that you are able to do what you want to do and at the same time not compromise the security of the system. The third way that we do this is this extension called Superutils. So if you haven't used Postgres before, the super user that you get by default with Postgres is pretty powerful. It can do a lot of different things. It can read and write to arbitrary files even outside the Postgres data directory, which when the first time I heard about it, I was like, sounded insane. But that's what you get with Postgres. And so to make but at the same time, we didn't want to say, hey, you don't get super user at all with Postgres. That would mean that you can't do the stuff that you want to do with Postgres if you don't have super user access. So with Superutils, what we did is that we started exposing all of this functionality to users in a secure way. We block the stuff that we don't want you to be doing, but at the same time, most of the functionality that you want as a super user, you still get with this extension. Again, this extension is open source. You can see how we sort of open source core parts of a security stack so that you can audit exactly what's going on inside your database. And we also recently added support for event triggers with this extension. Without that, it would have been very complicated to implement, and we are also upstreaming the support for event triggers without superuser into Postgres core so that anyone who's using Postgres, not just inside Supabase with this extension installed, can make use of event triggers. So that's hopefully gives you some idea about what we do to keep some of the things that we do to keep Supabase secure. And we also have a bunch of different primitives that you can use to build more secure apps. So one of the recent things that we launched is the support for asymmetric signing keys and API keys. So before, we have this long-lived API keys called service role key and anon key, and rotating them was always a pain because every time you have to rotate the JWT secret, it mostly means you're going to have some downtime associated with it. It was a very complex operation, which means that users didn't do that as often as they probably should be doing. And with the launch of asymmetric keys and API keys, you can do that much more easily without any downtime, and you are in much more control of how that process happens. And with asymmetric keys, also it eliminates one whole class of vulnerabilities because all the JWTs generated by Supabase auth is signed by a private key, which never leaves the auth server at all. So previously, users used to do some pretty interesting stuff, let's say, with the JWT secret that we didn't want them to be doing. But now with this, you can achieve similar stuff, but you don't expose the secret outside Supabase auth, which improves your overall security posture. The other thing that we have been putting quite a lot of effort on is this security advisor. This advisor has a bunch of common misconfigurations of Supabase. It's a great thing to run through before you launch your app or go to production. And we have been adding a bunch of different advisors and rules to flag common issues that we see before people go into production. And we have also been exposing these not just in our dashboard, but we also have a MCP tool that exposes the similar security warnings. So regardless of where you use Supabase from, like Figma or like Vercel V0, Lovable, whatever, you still get these warnings exposed to you so that the AI agent can, make reasonable decisions on what to fix when it comes to security of Supabase. The other things that we have launched recently and made it more self-serve is this project permissions. So with security, you obviously want the principle of least privilege to be adhered to as much as possible. So previously, org members could only have permissions associated with all projects. So if you have like a production project and a prototyping project, a developer used to have the same permissions for both. But with this feature that is on the Teams plan, you can assign certain roles to certain projects, to certain developers, and that makes it easier to have like a stronger security posture. You can also enforce MFA across all the members of your org. We are also launching secure peering with in private alpha with a few customers. So reach out to us if you're interested in this. But basically what this means is that your Supabase database, if you're only using it from, say, a few backend servers that you have and you're not using it on the client side, you can expose Supabase only to those backend servers, and you don't need to expose it to any other IP outside that. And finally, the code that you write with Supabase, like there are all these lints and primitives to help you write secure code, but ultimately if you decide to use an insecure NPM package in your edge function, it still means that you are insecure. So this part of the stack, the application code, the edge functions code, the SQL part is still your responsibility to make sure it's fully secure. And yeah, that in terms of what's coming, so that's some of the stuff that we have already launched. We are working on more granular permissions, so you can give a developer access to, say, just the edge functions, but not the database. This one is one I'm pretty excited by, is just-in-time database access. So we have built a custom authentication module for Postgres, which we just open sourced, but this lets you give just-in-time access to the database without sharing like your long-lived Postgres password directly to your developers. And we are also, as we release more features, we understand that it adds to the surface area of the product. We want you to be more in control and say, if you just want to use Supabase as a database, you can basically go in and turn off all the features that you don't use at Supabase. So that's something that's coming. We are working on allowing you to drain audit logs to your internal SIEM so that you can set up and monitor alerts based on that. We're working on ISO 27001 and scoped personal access tokens so that you can limit what resources access token that you generate has access to. Cool. Yeah, if you want to learn more about what primitives that we have for you to build secure apps, this is a link to our docs, or come find me. I'll be hanging around here. Thanks.
Cool, thank you. I think the last talk today is one I'm super excited for. Liz and Tyler are from the Teardown library, and they're going to talk about the first generation iPhone. So it might take a couple minutes for them to get mic'd up, but I will let them come up when they're ready. Okay, we're back. We have Tyler and Liz for the Teardown library, a live exploration of the first iPhone. I'm excited. Take it away.
Can everybody hear me? Hi. All right, everybody. Okay, this is like the weird talk. We're going to wrap up the day. Hi. It's been a while. Yeah. This is the hardware talk too. So we're going to dive into a first generation iPhone and talk about a lot of the stories behind this really groundbreaking product. Just for introductions, my name's Tyler. I'm a co-founder and GP at an early stage VC fund called Baukunst that's based here in San Francisco and Boston. We invest in pre-seed founders that are design-minded technologists and help them build great companies. But I have this side project on the side called the Teardown library that I'll explain a little bit more about. But also want to introduce Liz as well.
And then, hi everyone, my name is Liz. I used to work at Apple, not on iPhone, that was way before my day, but I used to work on Vision Pro. And then I used to work with a lot of people that worked on the OG iPhone at a startup called Humane. And then now I'm starting my own company. And I love collecting all this different technology. And so when I was in Shenzhen in January, I found a very rare iPhone 1, and I was telling Tyler about this, and so he pulled me in to help out.
Yeah. And Craig hit me up to do this at the conference, like the day after I was talking to Liz about this. I'm like, oh, we got to do this. This is amazing. It's too good to be true. So, back in 2006, I was working at Apple. I was in the iPod and iPhone team at the time that was really working on the kind of full life cycle of the products, from design, definition, through iterative engineering, prototyping, and then mass production in China as well too. So I kind of just wanted to walk through the story of the product together too. So this will be fun. But let me talk a little bit about the Teardown library. So the Teardown library is a group of product designers, and we get together regularly here in San Francisco to take apart products together. Sometimes they're new products, sometimes they're old classic historic products, and we dig into the guts, and it's very inspirational to see the high level concepts that trickle down to like specific design choices for the products themselves, and just a great place to get the humans together to kind of talk about what inspires them. And I think for most people developing physical products, like looking at what's been invented before is like as a first step to what we're doing. So this is really fun. If it sounds good, go to teardownlibrary.com and we'll get you on the invite list for this. But what we're doing here is very kind of like raw demo mode, and this is like what we do at all the events too. We're gonna have some stuff to pass around. And like I said, we're gonna talk about the very first iPhone. So let's go back in our mental time machines, 2007. This feels very like quaint now, but when Steve was standing on stage announcing this product, he jokingly talked about 3 products: a widescreen iPod with touch controls, a mobile phone, and a revolutionary internet device. And the internet device thing was like, no. That was kind of like the crickets part, like not as thunderous applause as the other bits. But in retrospect, was really maybe the most exciting part of what the phone was. And so much of like when we dig into the parts of the device, like really mirror these like 3 really just like essences of the product themselves. Like I said, I was there. I saw factories that started off as fields that became factories that had hundreds of thousands of people working at them. Many parts of the product, like the touchscreen, that was the component that I was like most directly involved developing, was largely done in like a class, whatever, 1000 clean room, doing sputtering, thin film deposition, like rigid-to-rigid lamination, really like a high-tech LCD manufacturing process. And the funny thing was, like, this obviously made huge impact at the time. This was kind of an iconic Time magazine cover. But this really like talked about the phone like it was some fully formed idea that like emerged from Steve's head at the time. And what it really was the confluence of these like decades-long evolutionary trails of a bunch of different underlying technology components to what a modern operating system looked like, what a browser could do on an embedded device, miniaturization from generations and generations of iPods, and the strategic relationships with vendors and supply chain around that, cellular technology, and maybe most importantly, multi-touch for the product as well too. So I think every overnight success is a decade in the making, and the phone is really like an illustration of that. So let's show some stuff. I've got a few different like cameras to bounce around between here, and I think this will be mostly like the easiest one to look at. This little light here is a USB microscope as well. So if anyone feels inspired, like
feel free. This can be very interactive. Like if you want to shout out and see like a tiny thing on the board, like we can really zoom in close here too if you want to. So that'll be fun. We may look at a few things. So, but let's get into it. So I'm going to just walk through the product at a very high level and talk about some of the kind of key defining features that I think were really innovative with the product, and both kind of like connect high-level product features, functionality with both the hardware and software underneath it. So let's see, what do we want to start with first? Maybe the touch stuff?
Yeah, or actually before that.
Oh yeah.
This is one of the first iPods, so just to show the continuation of this pretty much kickstarted the entire supply chain and all the relationships, and then the relationship with Foxconn that led to them being the contract manufacturer for iPhone 1. So maybe a backstory about how did the iPhone come to be and what is the Purple project?
Yeah, absolutely. So a lot of the work with the phone honestly like started from defensibility around mobile phones starting to play MP3s and Apple being worried that it was going to cannibalize the iPod market. I think it was very clear that that was happening. Like you might even remember some of that, like the rocker phone they did with T-Mobile and Motorola at the time for a while. That was a little bit of a dud. But I think they just really saw that phones were going to have that capability and people were only going to have one device in their pocket, and they had to do something about it. And there was a whole cycle of the product development. And the project had many different code names, but Purple was like one of the overarching ones. And there was a Purple and a P1 of the product that was a much simpler, less of a software platform, more like a phone, iPod Nano that existed for a while that just didn't really work. I think the interface was too fiddly, it just didn't really have that magic in it. And so the phone that we see today was really this kind of second generation P2 that got developed. And that really combined some stuff that had been in the works on the Mac side of the business for a while. But I think there was just something really magic there that clicked and was really the spark for the product.
And then it's the stories that I've heard from some of my past coworkers. It's actually really funny. The people that worked on that first Purple phone that used a click wheel, a lot of them actually got up and left when that was not the project that was going to move forward. And so they actually went to a company called Palm. And so they worked on the Palm Trio and all these other devices and on Palm OS. And so that later got acquired by HP. I see you have the jacket on. So it's funny to see how these things change. And they walked off because I don't know if they believed in the future of Apple or not, or the future of the iPhone, but it's funny to see in hindsight what has happened.
Yep. And a bunch of this stuff came out in like the Samsung lawsuit stuff too. So if you want to do some like internet sleuthing, it's pretty fun. We also brought a few phones to maybe like pass out if you want to too. So it's kind of fun to like click around on some of these. So I'm just going to hand a few of these out if you want to pass them
some
around.
of them are running iOS 1 and others are running iOS 3.
You look one.
And then we'll let you decide which one you're running.
Yeah, and just please give them back after. Okay, cool. So I'm just going to talk about the touchscreen itself. So it was a huge deal at the time to have a full touchscreen. I think there was, if you remember, a few like stylus PDAs that were like the resistive touchscreens, and it was a real hero feature that this was like going to be used with your finger, and Steve made a big deal of that on stage. But to really do that well and fast, and really have like be successful with the vision of the kind of inertial scrolling and direct content manipulation, you really needed a different touch sensor, and that was something that they knew a lot about from developing trackpad technology, and just had a concept to translate that to a transparent touch sensor that could live on top of a piece of glass that they were developing for quite some time. And that was just, you really just can't underscore how big of a paradigm shift that was for interface design. Not just having a separate pointing device that controlled something on the screen, but just like if you see a piece of content, like grab it, pinch it to make it bigger, scroll it around, was really, I think, a huge achievement and affordance for those products.
And Apple actually bought a startup that was working on multi-touch devices and screens, and so that became the team that pretty much worked on touchscreen out here. Yeah,
shout out Fingerworks. Yeah, they were a huge part of that, a really important acquisition. But I can show you a few of these of the pieces that did that. So basically, like the whole front of the product was a piece of cover glass, and it being glass, I'll get back to in a second. But this is a whole laminated stack where there's an LCD display behind here that has it has a backlight assembly that has like a row of LEDs and a whole set of films that like sit in this like a plastic P chassis behind the glass. There's two pieces of glass with like the liquid crystal itself in between it, and then those get a voltage applied, and it polarizes the liquid crystal and shines light through colored pixels on the screen. But that LCD itself is two pieces of glass, and then that's laminated together with another piece, a single piece of glass that has two sides of transparent conductors on either side of it that are patterned basically like rows on one side and columns on the other side of the glass that can do like finger tracking of multiple finger patches on the screen itself. And then that whole thing was laminated again to a piece of cover glass that was like the external part of the enclosure to the product. So this was incredibly challenging. I think it was the first time in the world that a piece of glass had ever been patterned on both sides with ITO like that. And those had to be, you know, optically aligned to the display as well too. So they were just huge, like room size, like the clean room picture I showed before was all custom robotics to do optical alignment of those pieces, laminate them together with no bubbles, no particles, and yeah, just like an incredible feat of engineering. And all of that was driven by a little signal processor chip that Broadcom developed. It was a custom silicon project for the phone, and that's all like attached by these flex circuits that actually get like bonded down to the edge of the glass itself too. So just an incredibly complex piece of hardware. That took years and years to develop. And originally the cover was a piece of like hard-coated plastic that we developed all the way through basically like when the product was announced too. And this was just one of those moments where like Steve just put his foot down, and I think he maybe had scratched a piece of the plastic covers in his pocket with keys and was like, it's got to be glass. And there was real trade-offs around it too, where like if you were going to drop your phone, it was going to shatter. It was way more fragile in those like failure cases. But in sort of the everyday case that everyone was going to see, it was going to get scratched up and really make the product feel weird. There's also a strange psychology in that too. I think when somebody drops their phone, they know they did something wrong, and when it gets scratched up, they think the device designer did something wrong too. So that's definitely a consideration. So yeah, that was the touchscreen.
Yeah, Tyler, I hear that when Steve actually got on stage and released the iPhone, it was still the plastic. And then a few months later, when the devices actually needed to ship, he said it should all be glass. So you were the head PM for touchscreen. How was that? Were you sleeping? Were you flying off to Shenzhen immediately?
Yeah, I mean, we had built like literally like 5 phones with glass covers, and it went from that to being like, we have to do this and like move heaven and earth. And if anyone's worked on hardware before, it was like DVT3. It was like right before you're supposed to go to production too, and we just like cut over, and then there was a DVT4, and then we just shipped it. So it was insane, and lots of other like architectural changes to make that happen too. There's like a whole, like the bezel was designed for a piece of plastic with a flange, and we had to make it work with gaskets with glass that didn't have the flange. It was just insane. And we were also testing lots of different kinds of glass, and like these samples from Corning were really the only ones that were strong enough to meet the engineering requirements. And so the operations team just like moved like heaven and earth to like scale this company that was like very technically sophisticated, but basically made dinnerware and you know, scaled them to a mass production consumer electronics powerhouse there today. So yeah, it was really incredible teamwork on both sides of the table there. But yeah, it was cool.
And I hear that Gorilla Glass was not a product that was super popular from Corning. So Corning had to spin up the entire supply chain just for iPhones.
Yes.
In the span of like a month or something,
Yes.
which is insane.
Yeah.
I also hear that the factories in Shenzhen had to be set up, and so there was a separate contractor working for touchscreens and glass, right?
Yep. Yeah, and I still like have my passport at the time that it's about like this thick, and there was so few glass covers that I would be hand carrying them through Hong Kong and to Japan and back to southern China myself, like on a day-to-day basis. I think that people at the airport counter like knew me by face. It was like, hey, like I was buying a bus ticket, and yeah, I'm glad I didn't get in trouble, but I did some low-key smuggling at the time, maybe. Let's see, what else to talk about? I kind of just want to dive a little bit into the software itself. So a really big deal with this device, obviously, is that it like ran fully fledged OS X, and that was really an evolutionary path, pun intended, like from the Next acquisition in Darwin all the way through that like build train, and like truly the work of decades of optimization and development from the software team. And it just took a lot of will to say like we're going to use that, like no compromises like on the device, and we're really going to build a platform for software. So that was really just incredible work, and just the fact that they've been developing a web browser in Safari themselves for so long and made a version that could work on the device was really incredible. That, I mean, everything else at the time, I don't know how many people use those phones that had these other like embedded like janky web browsers. They're just horrible. And so it was absolutely incredible to see like a real modern, like fully rendering web browser on the device. What else to say about that? So one of the like interesting things too was the processor at the time was actually a Samsung processor that was a custom development with Samsung, who had been making the like higher end chips for the iPods for quite some time. And so we just had a very, very deep relationship with them. And yeah, it was like ARM chips, very power efficient. And we just had a great collaboration, and we're effectively like many generations into this like class of chip design together. There was Samsung employees that were sitting in the same building with us full time for years at Apple, and they were a very, very, very close collaborator, and a huge part of like what made the software work. Yeah, tons of interesting stuff with this too. Like this has like a discrete DDR on the board, and like separate from the processor. This stuff would later become like a POP, like package on package, where the DDR would sit right on top of the SoC. They got developed later, but kind of in this first iteration, they were totally separate. These boards are actually sandwiched together, so you can see these board-to-board connectors here would actually kind of like mate and make a little like double-decker board that fits everything in together. So if you look at the let me just like show a picture of what a modern board looks like today. I mean, we're like this is like alien technology compared to what we're looking at here, where they're literally like stacking components in 3D. They look like a little cityscape where you almost can't see any PCB. It's just components, yeah. So we've come a long way. But even here, like this is like a quite tight packaging for electronics even today. So yeah, it's kind of amazing looking at something that's almost 20 years old at this point. Yeah, so that's great. You can also see, like, look how big, this is the SIM card connector. This is like huge. This is just like screaming, like, design me out. Like, so much cost, and now, like, not only are we building that, but then we're building like a little aluminum tray to go in. There's a hole in the outside of the enclosure that's gonna let water in. It's like expensive, and so this stuff is just like, Walking Dead. It took years and years and years to make it finally go away. And SIM cards are ridiculous too. They're actually like have little mini operating systems. They run Java applets. You can there's horoscope apps that run on most SIM cards right now that yeah. Yes, I think they maybe a lighter version of DIM, yeah. But anyways, we're in like a warpath for SIM cards to go away or to become eSIMs for a long time. They're just bad. So let's see, what else to talk about?
The first Apple processor to go into iPhones was the A4 and iPhone 4.
Yes.
So it took like 3 or 4 years for it to finally be moved out.
Yes, exactly. Also, let's just take a look at the camera. I mean, look at this little adorable thing. Aw.
It's 2 megapixels.
2 megapixels.
Adorable.
Fixed focus. So no autofocus, no HDR, just a tiny little camera. And if you've noticed from the phones we're passing around too, you can't take video. It was just photo only. I mean, it's just one of these incredible MVP moments for the product too, where you could really see how that as almost like skill tree was going to be really important for the product in the future. But it's like, let's do the babyest version of it with a pretty well engineered third party module, and then design around when we needed to.
It's also crazy, OIS, optical image stabilization, only came into iPhones in 2014. And so the Windows Phone actually beat Apple to OIS.
Yep, totally.
And now cameras are the main thing on iPhones, which is quite incredible to see.
Yep. Absolutely. And talking about board space, like this is the battery, pretty unremarkable. It was actually soldered directly to the board and like taped down to this metal piece inside, so it was like incredibly non-repairable. And some of that was done for form factor. Some of it was really just sort of an ID decision, so that you had this like beautiful jewel-like stone of an object, and it didn't have fiddly doors that would fall off and swappable batteries. But that was like an incredibly opinionated design choice at the time, where BlackBerry users were carrying around multiple batteries to swap out all the time, and so yeah, there was a lot of hand wringing about that at the time, and it would have been nice to be able to repair it more, but yeah, that was a choice. But this is about half the capacity that's in the modern phones today too. So it's incredible to be able to like double the battery capacity in a device that's effectively the same size. So yeah, they made the phones a little bit bigger, the battery chemistry got a little bit better, and then they just like cruelly like removed all these other components from the product over time. And you can see like here, this is the 30-pin connector that the big like charging cable would fit into, and a bunch of those connectors just like have to go over time. The audio jack was quite big. This was another really big deal, that it just had an audio jack. Like almost no phones just fit a normal like 3.5mm audio jack at the time, and that was really about it, like fulfilling that like it is an iPod vision, and was yeah, it was really cool.
It's also interesting on the audio jack, you can see this little red piece right here. And so, ooh, where is this? There you go. And so that, when the iPhone got into water, it will actually make this white dot that you see in the jack itself turn red. And so they kind of thought ahead. So if you by accident dropped your new iPhone into the sink or something, they knew exactly what you did. And so that's some good thinking on their part.
Yeah, it's a very like adversarial customer service feature, but they knew when your like phone magically stopped working, whose fault it was sometimes. So yeah, this is just like a little piece of ink that basically soaks into like a white piece of paper behind it, and then you can see it through the audio jack. It's really amazing. But waterproofness is like a huge feature of the products today. Like I think really incredible for users. Really like reduces the in-warranty return of the devices. And it's just like an incredible effort to get to where we are today, and you can basically go scuba diving with iPhones. This thing is like, there's like almost no water mitigation. Like water will just pour straight through this thing, and it's fun. Yes, you have a question?
You pointed out the 30-pin connector.
Yep.
That looks like a very long trace.
Mm-hmm.
Why does it do that? Delay or?
Well, actually, in the layout of the product, the 30-pin is at the bottom, kind of in the chin of the device, and most of the MLB like lives up in the forehead, and so you just have to get up there.
So why though not just a straight line? Why this path?
Yes. So it actually, this is a service loop, and so this flex actually had to be kind of bend in the assembly and disassembly of the product. So there's a little slot. I may have it backwards here actually, but this. Yeah, the cable actually like snakes through the stainless steel midplate of the device. So, and you have to kind of like cycle it when you're snapping the shell together. So, yeah, any like bends like that are really just service loops so that the assembly works. Yep. The 30-pin also like incredible. Like at the time, if you remember, it actually did analog audio out, which was like very important for the accessories ecosystem, where you could have a very dumb speaker that just could play, all your iHome devices at the time, and every hotel room had them. Very important. But it also did analog video out on most of these devices too, that you kind of needed a special dongle for. But it was pretty incredible. Yeah. So let's see, what else should we talk about?
Tyler, another question. So the iPhone 1 was notorious for not being compatible with 3G, even though 3G was the standard back in the day. Instead, it was GPRS, which is 2.5G. Can you tell us more about it and more about the RF stack? Yeah,
absolutely. So there's like a Infineon modem and some other like bits from Skyworks on here, like the front end on the radio. But basically, it all came down to like cost, form factor, and maybe most importantly, battery life. The 3G modems at the time just really didn't support the usage that like a modern web browser would need in a device like this too. So we kind of just like, that was just saved for the future. It's like when we get a next gen modem, that'll like make the whole kind of like design equation close. But for now, like the sort of like trickle rate is enough. And I forget what edge was. It was like 400 kilobits per second or something like that, max. It was like very, 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 very slow. But yeah, it was kind of a step in the right direction. And it worked on Wi-Fi too, which was like the main use case.
And it was a quick follow-up because then in 2008, they released the iPhone 3G, which supported 3G systems. It's also interesting here on the back, you can see it says FCC ID. And so back before 2014, every single device was required on the body of the device to print the FCC ID for the certification for selling in the United States. And then in 2014, there were some very clever people in Apple that actually went and lobbied the FCC. And so now you can actually put that FCC logo in the settings app. So if you go into settings now and go to certifications, you can see that certification. So that's a fun fact about how Apple wanted to clean up the back of the phone. And so they slowly over time did so.
And this you can see this like flex circuit. That's the cellular antenna too. And so it basically is a kind of like flexible conductor that's just taped down and holds its shape with this like plastic cap that it can radiate through on the back of the device. So that was how the design was done at the time. That stuff like later like migrates like famously to actually being integrated to parts of the to part of the outside of the frame, like i.e. antenna gate with the iPhone 4 that improved over time, but that was like a huge technological step once we get to like this generation of the devices. But the other crazy like MVP thing is that this thing did not have GPS when it started. It's like a phone knowing where it is in the world is like so fundamental to like what we think about mobile devices. And this just used the like Wi-Fi based like skyhooks kind of triangulation to locate the devices. It didn't have a compass. You didn't know which way you're facing. Like you were still like, you know, if you were looking at maps, you would like take a few steps, like have to walk a block to even know which way you're pointing in like a city still too. It's just kind of incredible how little like situational and contextual awareness the devices had at the time.
And then Tyler, what is this plastic piece?
Oh, this little guy? This is, oh, this one? This is really just a cap that went on the back of the device that is plastic instead of aluminum that let the cell radio, or the antenna radiate through the device. Yep. One of the really important things that we're talking about cellular technology, one of the most important things the phone did was actually a business model innovation that unlocked the whole product itself. And so Apple was able to negotiate subsidies with the carriers, so they were getting paid hundreds of dollars like whenever a new iPhone customer joined AT&T, and they basically took the LTV from the data plans that they were selling and like pulled that forward to like the point of sale for themselves, and they used those dollars to subsidize the hardware of the device itself. And so there's just like an incredible amount of cost in the first generation device that wouldn't have been possible if it wasn't for the carrier subsidies. And lots of the big meaty stuff like all of the sensors and the touchscreen and things like that. But also there's just some bonkers components too. Like this bezel is cut from a single piece of stainless steel. And if you do any machining, like machining steel is like one of the worst. And this was cut out of a single block for every single phone. Extremely expensive, but very, very beautiful and also very functional. It provides a lot of like rigidity for the mechanical stack of the phone too. Stronger, yeah. The which one? Yep. Kind of just the trash can. It's just like chips, yeah. You can like melt it down and resmelt it and everything, and it probably was used somewhere. I'm sure a very resourceful vendor, did something with it, but not in the main design of the product.
Tyler, looking at all of this, which thing gives you the most nightmares?
Definitely the glass. I mean, like the switching to glass from plastic at the last minute was a total insane move that ended up working out well. But that's like, yes.
Do you have infinite United points for life now?
Yeah, I've used them all up at this point, but I was, very high status for a little while. Yeah.
So a fun fact is that Apple actually started buying full flights from United. So they convinced United to make a flight from San Francisco directly to, I think it was Shenzhen or Shanghai, one of those places. And so they would constantly buy out enough first class seats to make it worth it for United to run that flight.
Cool.
And that lasted up until COVID, I think.
Yeah.
Internal test for a multi-touch or glass touch screen before this, or was this the first device that used multi-touch and glass in the?
Yeah, this was This needed a new test methodology for multi-touch. Some of the trackpads had similar testing approaches, but were not like true multi-touch in the same way. But yeah, there was a very like low level like does the hardware work test where there was a PCB with basically pixels that you could fire test patterns. You could put the screens face down and like simulate all the touch patterns. That was a really quick test. But all the higher level stuff of like is our touch resolution what we want for finger pads fingers of different sizes. Like can we hit keyboards strokes the same way? Does pinch and zoom and the smoothness of scrolling feel good? Like all of that really had to get polished and was integrated with the pixel UI design itself all the way down to like the touch sensor and refresh rate and all that. So that was like highly iterative to get something that converged that felt right. We're at time now too, but I think we're the last talk for today, so I'm just going to keep answering questions until somebody kicks me off.
Should we show some of the hardware software prototypes and how?
Oh yes! Oh my gosh! Yeah, I got to show this real quick too before you guys leave. These are really good.
Wild stuff. So Apple has a crazy culture of secrecy. And so if you were working on the software team, you actually had no idea how the hardware looked like. If you were working on the hardware team, you had no idea how the software looked like. And so this was the setup that the software engineers used. And so you have a G3 Mac, which pretty much has the same power as one of these Samsung chipsets.
But it was out of date at the time too. Like they purposely picked old computers.
It was like a few years old. And then you have right here in the corner, you have what is called a Wallaby.
This guy.
And so it's pretty much just like a touchscreen screen, but then you would code everything in Objective-C on the Mac itself and then run the process on the Wallaby. And so this is what everyone was using to develop all the apps that you saw. So the team that developed all the original apps was, I think, only like 25 people. And so, for example, my old boss, Ken, he was the one that developed a touchscreen keyboard. And so the story behind the keyboard was if you need to make a touchscreen device like this work, you need a working keyboard. And the touch resolution back in the day was not great. And so they had a whole hackathon, pretty much all hands on deck, who can create the best touchscreen. And then his design ended up winning. And I think he went through dozens and dozens of designs until he made this version of autocorrect that actually made the touchscreen pretty accurate. And that's what made iPhone.
Yep. And one more MVP thing, like no copy and paste, famously. And this was, once the product was a little bit more mature, this was like the dev board that was like represented the entire locked system of the phone, but you could still work with like a tethered device at the time too. And this is just like good prototyping 101, where you want to decouple the like looks like and works like development tracks of any product you're working on too, to make sure you're like building it right and building the right thing kind of separately. So really important, part of the development cycle.
Should we show what the firmware engineers saw in the factory test?
Oh yeah, and then this one, this is really funny. This was a version of the UI that was called Skank Phone. I think just because it looked ugly, it's like maybe not the best name overall. But this was a kind of like fake UI that existed on all the devices that was used as like diagnostics at the factory to be able to simulate all of the high-level features of the product, and like software QA testing could operate the device, but then kept all the real UI hidden, but sort of like mimicked everything without the fully screened UI at the end.
And so this is what they were using for testing at the factory. Tyler, how was the culture? So how was it like working with the Foxconn engineers, and were you sleeping on the factory floor all the time?
Yeah, I mean, yeah, it was lots of like multiple shifts at the factory, very little sleep a lot of times, but really like family. I actually don't have all the pictures handy, but like I would go, like we would play pickup basketball games with the Foxconn engineers at the time. Some of them were really good too, and it was very fun. It was like I knew their families, I knew their kids, and it was very much like one big family with the people that were spending just like their every waking hour together at the time. So that was just like an incredibly like trusted partnership. But yeah, like all of the secrecy that's so famous at the company was totally true too. For a while, my direct manager did not know what I was working on. He would just be like, "Are you happy?" And then I'd be like, "Yes." And I was like, "Please sign my expense report." And he'd be like, "Great." It's like, "Why do you have a $2,000 cell bill?" This and it's like, don't worry about it. I had to go back to, I was in between China and Japan a lot. And so that was very true. And I think because of the parts of the phone that I was working on, I sort of had like the most access to a lot of different groups, and was oftentimes like a glue between groups in the company that didn't talk to each other very much. So I would often, because I was working on such a functional cosmetic device, I would talk to the UI team and the ID team, and and software. And so I was really sort of like a go-between that was around a lot. But that was a big part of the company culture at the time. Yeah. But it was actually really wild. Like we had an all-hands meeting with Steve where he it was one of like the hardest times that everyone was really like burning the midnight oil, not spending time with friends and family, and he just like acknowledged that and said like this group reminds me of what the Mac team was like back in the day. All of this effort that we put into these like incredibly small details are actually little like love letters to the users that use our products, and it's just a really meaningful pep talk that I really hold with me today. But he said like more people are going to be working on this type of product than anything else in the company at the time, and it was crazy to think that at the time. You know, we had very like conservative sales estimates, and it really felt like an experiment, but he just like was all in on like this is the future of personal computing, and we'll use every ounce of the company's resources to make it happen. So really incredible to see. Yes.
What was it like working in like such secrecy? Like you can't tell anyone about amazing technology.
Yeah, it's hard. You really want to tell it. You really want to talk about it with people. But for me, like you know, there were extreme versions of that sometimes. But really, like when you have extremely high levels of give a shit about something you're working on, especially if you're really putting yourself into it, like a creative project, like creative writing or a piece of music you might be working on, you really don't want to show it to people until it's ready. And that was more of like what it felt like at the time too. It was like I can't wait to show this to people, but it's not quite ready, and it's because I like care so much about this and I put myself into it that like I want to hold off. So it was more like positive than negative for me overall.
So, two quick questions.
Yep.
When each new iPhone comes out, are you like ever critical about it? Like, oh, that's
Now?
Yeah.
Oh yeah. And at the time too, yeah.
What's the most recent thing that
Yeah.
you would say you're a little critical about?
No, I just, for me, there's like, I think it's it makes sense how the product line has matured over time too. I mean, I think like if you look at like generation to generation, the products feel pretty similar. I actually don't even know what number iPhone I have in my pocket. I have to like check the settings screen or something too. So it's already become this like meta device for me that just sort of like exists. It's like a ship of Theseus that I just like upgrade the hardware over time. And so, but I think that makes sense. I think that's like the role that it plays in our lives these days. And if you think about how stable like even the MacBook Pros have been over time too, like they're kind of just like an iconic thing that like, you know, you want it to work really well, and it should be like a bedrock of how you use the device. And I think it's like makes sense that the phone became that, but like, I don't know, I just like, I don't have the same like, you know, life-changing inspiration, you know, all the time too, so yeah.
Last question was, what do you think Steve would think of the new iPhones if he was still alive?
Yeah, totally hard to say. Like it's really hard to speculate on that. I think that some of the decisions that were made around really optimizing around the camera experience just feels very like opinionated, and like we just went all in on that, and we're seeing the fruits of you know decade-long development cycles that were really invested in some core technology that are really coming to fruition now, and so that feels very familiar to me too, but really hard to say like what do you think?
You also see the same in software. Like, did you see the iPhone 1? Did you play with it? It literally feels exactly the same as it does now. And so there's on iOS 1, iOS 4 released multitask for app switching, and then iOS 7 was the latest jump. And then ever since then, it looks very similar. And so I think we've just plateaued in terms of iPhones.
Oh, I'll be critical. I hate bigger screens. I want the mini back. Like this feels so nice to be able to reach everywhere on the screen. Oh my God. It's criminal that the mini is gone, so that's my biggest thing. Yeah.
Tyler, another question. So I hear iPhone 1, it was a success, but it was not an overnight success. So the first year, there was actually a lot of articles being written about how, oh, the iPhone is nothing special, it's gonna go away, it does not have GPS, it was 2.5G. It was pretty outdated already when it came out. But then now, of course, who here has an iPhone? Just raise your hand. That's crazy. So if we asked this question in 2006, no one here would have iPhones, obviously, but also everyone would have different devices than the person you're sitting next to, versus now all of us have a device from the exact same company, which is probably the first time in history something like this is happening, apart from the monopoly Bell Telephone had back in the 60s and 70s. So back in the day, did you all know what was going to happen now? Was there this sense of anticipation that this device was going to change everything?
Yeah, I think that was there, and there's a lot of things you can look at, from like silicon design to manufacturing processes, like like for instance taking a prototyping process of like CNCing a piece of metal and scaling that to mass production was like kind of insane. But a lot of those decisions, and some similar things have happened with display technology and software too. But if you think about it, all of those things get better with scale. And that's like the crazy unlock. If you just like lean into that, where you don't get kind of ahead of yourself and just get appropriate like jumps and scale over time, that's very, very defensible moat over time. And that's why like Elon Musk has an iPhone, right? Like you cannot buy a better phone than an iPhone, and it's because the best phone is the one that the whole world has, because those economies of scale actually translate to the better products in those cases. And so that's a really like guiding like strategic point, I think, too, of like really thinking about whether the like your technology roadmap like has that same pattern at the like right levels of scale over time. So if you lean into that, it's a really, really powerful moat. Yeah.
I see that. It's also crazy just looking at the history of this design. Like slide to unlock, that sound is one of the UI designers' pretty much high school locker locks, which is kind of crazy that he put into the device itself. Also, if you look at the screen, all these apps are going to look very familiar. You're going to see the exact same ones on Xiaomi and Huawei and all these other phones that look very similar to iPhones. But there's some decisions here that I think are really incredible, like Messages, Phone, and Contacts being 3 different apps. They could be one app called the People app. And so back, the design team for our iPhone was only 5 people. They were thinking through all these decisions, like what apps do you have, which apps do you need, which ones do you not. And the story that I've heard goes that Steve wanted the iPhone to have more icons on the grid to make it seem as though the iPhone can do more than what it can actually do when it was first released. And so they split up all these 3 apps that can be one app called People into 3 apps. And to this day, Messages is separate from Contacts, is separate from Phone, even though if you combine everything, we would be communicating in completely different ways 15 years later. So small decisions like that, including the red notification badge, that have followed us in our computing practices.
Yeah. What do you think about the red badge?
Oh my God. It's interesting. When we talk about the unintended consequences of design decisions, I think the red badge is the perfect example of that. And so who here has their phone in grayscale?
Ooh.
Okay, nice. Yeah, it's one of those small decisions that someone made back in the day because they probably thought that people are not going to have that many messages or notifications. And so now, 15 years later, we're seeing the consequences.
Yep. Yeah, it's like terrifying. Yes?
Even with the App Store, right? So iPhone only started becoming super popular when the App Store came out in 2008. And then that's when things skyrocketed. And so no one expected, who worked on the OG iPhone, that TikTok was going to be a thing, for example, or Facebook.
Yeah, like iPhone was already an incredible device, but also an MVP in many ways.
Totally.
Like, what was one of those features that you wish you could have squeezed in and was so much?
That's a good question. I think that, I mean, everything that we talked about was already kind of like on the chopping block. So I don't know that there was like necessarily like a regret or one where the line was drawn in like the wrong place. But certainly like having stronger location services was like would have been like killer. And 3G, I think too. Like the phone really didn't take off till the iPhone 3G. I think that was like when it was a much like bigger unlock for people where they could really use it on the go. Yeah, and obviously maybe like we didn't talk about the App Store yet either, but like, you know, I think there was explicitly anti-App Store from the very beginning, but it just became immediately like very obvious that more people had ideas for what to build on the phone, and so it was the right thing to open it up over time. But that was definitely like a learning process where I think the inclination at first was very much to be anti. Yes, Jesse.
What do you think about when you watch your kids interact with your phone, and just thinking about how it's such a game changer the way they engage with it over the way we did.
Yeah.
From the get-go. Do you have like a unique perspective on that because of the work that you did?
Totally. I mean, I try to keep it, my kids are 3 and 5, so they're like, I kind of try to keep it away as much as I can, but you can only do it so much. But the crazy thing is they just see you like attached to it all the time, and it's just like, extension of your body all the time. And so I see them playing with like wood chips, and they're like, "This is my phone." I'm like, "Oh my god!" Like, just and so like it's just turned into this other almost like baby doll thing that they just like know is like as a human accessory that's with them all the time. That's like really complicated and pretty dark. But and tons of the interface stuff. Like a kid that like sees a screen and touches it, it doesn't do anything. They think it's broken. And I think that's going to happen pretty soon with people talking at things that don't talk back to them too. That's going to be weird. So that's like I'm kind of thinking about where that's going in the future too. So or whether they just assume that everything's listening to them all the time too, and what does that do? So that's, yeah.
It's a brave new world.
Brave. Yes.
During developing, what was one thing that was near the line of impossibility that you were like, ooh, I wish we could do this, but the technology's not there yet, so we may have to wait for it?
Yeah, I think it was a lot of, it was kind of just like the practical space of like bandwidth between cameras and processors and like whether you could do video or not at the time, kind of what the like system requirements would be to do something like that. Yeah, I think like the reality of some of the like cell technology and just like maybe like the SIM card we were talking about too. There's some obvious stuff in there. It's just like this is terrible and like we have to do this. We have to use what exists in the world today in a practical way to do like what's here, but like it's very clear like how things should be different 5 or 10 years in the future. Yeah.
On the SIM card part, it was really surprising to me that the iPhone does now run a Qualcomm chipset for a modem. And so that only was 3G, I assume, of CDMA protocols. And so it's interesting to see how companies that we now talk about all the time, like Qualcomm, have come into the picture for these latest like cellular technologies as well. That enabled so much and enabled the App Store as well.
Yep, totally, yes.
I saw in a documentary about earlier Apple hardware desktops and stuff that one of the big areas of innovation was power management and some of the engineering on that side.
Yep.
I saw your test rig where with how the software engineers didn't see the actual hardware. I have to imagine the hardware team is itself not monolithic for a product like this. But how did you guys have any kerfuffles with like this power management thing wasn't going to fit like that?
I mean, I would just say that it's a huge area of innovation. I might actually point at the wrong chip, but the power manager is a custom piece of silicon that, in most of the Apple devices, like the power manager is a custom piece of silicon that's very specifically featured to exactly what they want. That like breaks out the exact power rails you want with the right power sequence. And it's a really like strategic piece of one of the chipsets in the devices that like other people would sometimes like break out into individual components.
Was that itself an isolated part of the hardware team?
It was fairly integrated actually. Like there were some people that were a little bit more like power focused, but they still like swung like into general like system integrator roles on the team.
I know, like Corning, some of the like their stuff is like they do fewer patents than they have trade secrets. They just keep a lot of R&D.
Totally. Most of that was still done collaboratively with a third-party vendor like Dialog or something like that would work on the silicon themselves. But there's definitely a lot of internal knowledge. Like one of my like most important mentors is this guy Wendell Sander, who was like employee 18 at Apple, and he actually worked back at like Fairchild back in the day, just like really incredible like engineering heritage. And his son Brian Sander was the director of hardware engineering in the iPod, and Wendell like worked for Brian still at the time too, and he was just sort of like gray-haired emeritus. Kind of in the office, and he just like was master of the spreadsheet, like the power spreadsheet, and he had his own like Wendell fudge numbers, and it was just like whatever Wendell said is what the marketing team would like put on the box because he had done it for so long too. So there was a little bit of that like institutional knowledge for sure. Yeah, cool. I think we're at time to wrap up again the signal, but we'll stick around here. I can chat up front, but we'll like let the rest of the crew that's like doing stuff. Oh, I'm out. Just kidding. Bye.
Do you want to take a group across the street with you? Because
no, it's okay.
The only thing is that this space needs to close for an hour and a half so we can set up the closing reception. So we've got a whole different AV set up with DJ, food vendor.